Welcome back to this Black Hat Fast Chat video series. I'm Terry Sweeney, contributing editor with Black Hat, and I'm joined now by Chaim Hellman, who is the CTO of Carbon Black App Security at VMware. Chaim, thanks for joining us today.
Thank you. It's great to be here.
Our topic is speed versus security, best practices for securing containers without the trade-offs. Super timely topic. Talk about some of the top container security risks that companies typically face.
So first, we need to understand what are attackers looking for when they try to attack Kubernetes or a cloud-native environment. Currently, the most common goal for attackers is crypto mining. So they want to be able to run their own workloads on the attackers on the target resources. A second goal is secrets. So cloud-native environments and containers are full of tokens, credentials, passwords that in the hand of an attacker can be used to mount a second attack on very sensitive databases or storage resources of the organization. The third goal is to bypass the perimeter security of the organization and create a beachhead that can be used to start a lateral movement campaign.
Okay, so these targets are quite rich with the treasure trove that they may offer to hackers or intruders.
Yes, definitely. And when we're looking at what attackers are looking for in those environments, there are a few ways that are pretty common when attackers look at cloud-native environments. The first one is the misconfigured management API. So if we're looking at Kubernetes, that would be your API server. And if you have an endpoint that's exposed to the outside world with lacking authentication or authorization in place, then that could be a very easy path for an attacker to go through. A second approach is by introducing malware into public images. So we have a lot of open source in this environment, and developers are just, in many cases, downloading images from public registries that once the container is run, will connect to the outside world, download some additional tools, and start an attack campaign. Another common attack vector is the exposed application API endpoint. So now we're not talking about the cluster infrastructure, but really any application that's deployed in a cloud-native environment. The use of infrastructure as code makes it really, really easy to expose services to the internet. And if such a service that doesn't have the necessary security control, the necessary authentication and authorization in place, if such a service is exposed, that could be a very convenient first step for an attacker.
Okay. So why not just use conventional security technologies to address this? Are there specific container-related challenges that are proving really challenging to the InfoSec professionals that monitor all this?
So to understand why the existing tools and methods are inadequate, we first need to understand why people are using containers in the first place. Companies are moving to cloud-native technologies because they want a more agile development process and a more scalable and flexible runtime environment. So that creates a couple of types of challenges. You have your technical challenges. So now this is a more scalable and dynamic environment, and existing runtime security tools, they're used to kind of an affinity between the network identity and workload identity. So I know that this server is running this workload. In a cloud-native environment, this doesn't hold anymore. You have containers going up and down. They're ephemeral, and kind of tracking the behavior of a workload has to do with the identity of the workload rather than the identity of the server that is running that workload. The other kind of challenge is the cultural or organizational challenge. We have now an agile development process with a continuous integration, continuous deployment attached to it. So you have to have your security tools embedded in those processes and not become a roadblock. So you want to provide guardrails for your developers to make sure that they don't introduce unnecessary risks, but you can't really stop and have an audit for every software release. You have to be a lot more aligned to the way DevOps is operating today. Another challenge is, again, the massive use of open source that's required for agility. So we want to be able to take advantage of the work of other people and not to have to repeat everything ourselves. And open source is a huge driver of innovation and agility. It does introduce new security challenges, both in terms of vulnerabilities and potential malware.
What then do you advise companies that are struggling between that trade-off between wanting the speed and performance versus knowing they also need to secure everything that they're doing in these container environments?
So I think the most important thing is to understand that this is not necessarily a trade-off. In many cases, cloud-native environments, because of their flexibility and agility, are actually easier to secure than traditional environments. We know from past experience that we have in any organization servers running old versions of operating systems, old versions of applications with known vulnerabilities, and those vulnerabilities are the ones most likely to be exploited. In the cloud-native environment, upgrading is constant. The change is constant. Everything changes all the time, and that includes security patches. So it is much easier to introduce a new version that patches a known vulnerability in a cloud-native environment compared to where we were before. So there is actually an advantage of going cloud-native. Another thing that companies should do, and many of them do, is create this alliance between the product security, application security team with the DevOps and the developer teams in order to make sure that security isn't an afterthought. And by defining application security metrics for the developers and the DevOps team, everyone is accountable for eventually delivering secure software. And again, the platform itself is also very important. You want to use a secure platform. So either it's one offered by a public cloud provider, or it could be by one of the enterprise grade Kubernetes providers, such as VMware. So using a secure platform is a first step in mitigating potential attacks.
Makes sense. What about any tips or best practices for developers and InfoSec professionals who have to defend containers?
So first recommendation is stay recent. Whether it's your infrastructure, the level, the version of Kubernetes that you're running, make sure it's a recent one. Again, security vulnerabilities are found constantly and fixed constantly. The same applies for open source that you're using. Make sure to upgrade to later versions which are usually more secure than older versions. Take advantage of the fact that this is a dynamic and agile environment. A second tip is make sure your authentication and authorization is sound. There are multiple ways to authenticate users and applications when it comes to cloud native, and some of them are easy to implement but not very secure. Others have been widely used in the past, whether it's cloud-based authentication or your Active Directory authentication. So leveraging those existing tools in order to create strong authentication is important. Define your role-based access control to offer least privilege access to your users. Employ change management. So make sure that things that are introduced into your production environment are done in a repeatable way through a continuous deployment process and not manually just by users. Perform vulnerability scanning, not just for your container images, but your source code too. We have a lot of organizations moving to languages like Golang, which eventually create a binary. So just looking at the image doesn't give you a lot of information about the potential vulnerabilities in your code. So scanning your source code for vulnerabilities is important. And the same applies to scanning your infrastructure as code. So you have your YAML files and your Helm charts that define how your workloads are going to run and what privileges are they going to have, and what exposure are they going to have over the network. So scanning those using either open source or commercial tools and looking for known security risks is extremely important. Controlling the exposure of your workloads, either the inbound traffic through limiting it to a single point of ingress, limiting the egress traffic leaving your cluster is an advanced but important step, and eventually deploy some kind of a runtime threat detection tool in your environment. Falco is probably the most well-known open source tool for that. There are other commercial tools as well.
Great perspectives on the important topic of container security. Chaim, thanks for joining us today.
Thank you.
We've been talking with Chaim Hellman of VMware Carbon Black. This has been Terry Sweeney for Black Hat Fast Chat. We'll see you next time.